Yes. So you have your spatial transformation, which goes from gamma to gamma, and you have your image, which goes from 2-dimension to 2-dimension, velocity fields, and all continuous velocity fields, which is continuous piecewise defined, and which goes from gamma to R2, and then you have your manifold and the plane. You do spatial transformation from here to here. And what is the spatial transformation, which is exponential Yes, that's the meaning of the spatial transformation, and how you do plug to an image and then do this kind of work. So I'm also going to say something about dimensionality. Guys, can you look for a moment? I would like to say you about dimensionality. Frederick, let's just say also come here. Yep, everybody knows that we have MNIST dataset. And this dataset. Yes, are you ready? Yeah, I think for you. Yeah, so as you know, we have the dimension of MNIST dataset is 28 by 28, right? 28 by 28. So we are in 2 dimensions. Can you see? But we would like, if we have a spatial transformation, we would like to be in 3 dimensions. That's why we sample that, right? I think in PyTorch demo 1, you have seen some kind of n equal with 9, which they sample that from 2 dimension to 3 dimension, image 2 dimension, and then you will, by sampling that, you will bring your image to 3 dimension. So that's why I use a sample just 128 by 28. One is my sample from 2 dimension to 3 dimensions. And you know, normally the computer can see an image like 28 by 28, and the third one is RGB, right? It should be 3 if it's a color image, but we have just here 1 because it's not RGB. So the dimension of your image should be 128, 28, and then 1. But PyTorch can read that one. It can read like, you should, I think, reshape the image to 128 by 28. The first one is sample 1 from here and 28 heights, and that's the dimensionality error. So when you put to the optimization step, the dimension of your image should be this one. So, and you may see something here or something which is 0, batch size 3, RGB 1, 2, width and height, and you should use this one, or otherwise you will get dimensionality error. I think it should be 1 here, okay, but we will see. We run the code and see if it works or not. So n
equals to 9 equals to number of samples.
N is number of samples, yeah. For PyTorch demo, they have the shape of image like 350, 350, and then they have cat image, which is gallery image, is 3 here, right? Then they bring that to this dimension with 360. This is the dimension of.
I mean, when we printed the data, cat image, then we see that if n equals to 9, then we get 9 different transformations of the cat image. If we put like n equals to 2, then we get 2 transformation of the cat image.
Yeah, I think they repeat 9 times, right? But we don't need here. We just use this one to bring 2 dimension to 3 dimension.
And one more question is, in the code there is data divided by 252.
Yeah, they normalize data, right? When we divide that to 252, we just normalize the image to bring that, you know, between 0 and 1.
Okay.
Yeah. Is it clear, dimension? Otherwise, yeah, if you get dimensionality error, I'm here to help you. Yeah, that's for dimensionality.
The permute function which you call, is that the PyTorch or is that their own?
I think it's in PyTorch. Yeah, yeah. I had too much challenge with that one, but I think I tried this one. 1, 2. It doesn't work. Yeah, we will see.